Today we continue our study of Unit 1.1 with Section 2, which is all about segments, rays, and distance. Before we get into the new material, let's review what we learned yesterday about the notation for lines. In our warm-up, it says name the line below in 5 different ways, and there are actually 7 different ways to name the line. One way in which we can name this line is just to use this lowercase letter j. You can write the word line in front of it, or you could just use that lowercase j. We'll know that we're referring to line j. Another way in which we can name the line is to use 2 points on the line, such as AC. It doesn't matter if we name it AC or CA. That's still the same line, so those are 2 more ways to name the line. If we continue in that way, we can also name this line AB, and of course, BA. We can also name the line CB or BC. And don't worry, usually we just ask you 1 or 2 questions where you have to name the line in more than one way, so you usually don't have to make this big list. A line segment has finite length. It's something that we can measure in centimeters, feet, inches, miles. Now, similar to a line, we'll have points on this line, but those points are, or 2 of those points are the endpoints of the line segment. And we use those endpoints to name the line segment. And of course, above the 2 points that we use to name the line segment, we have to use the symbol as well. So this line segment can be named line segment AB with capital letters or line segment BA. If we included another point on our line, such as point C, AC would name a different line segment altogether. So when you're naming a line segment, it's important that you just use the endpoints. Our next geometric object is a ray. A ray extends infinitely in only one direction, as opposed to a line which goes infinitely in 2 directions. A ray has a definite endpoint. We're going to call our endpoint point A in this case. So this ray starts at point A and goes through point B. For the notation, I think you're getting the hang of this. We use the symbol and points to name each of these objects, and this is no different. We have to use the endpoint first, so we have point A first, then it goes through point B, and notice that the ray on top of our 2 capital letters goes from the left to the right. The rays always point from left to right. So we would say that this is the ray starting at A through point B. Now some people get confused and they try to name a ray in different ways. You cannot name it ray BA with the arrow going to the right. That's incorrect. You can also not use BA with the arrow going to the left. That's inappropriate too. Okay, so start with the endpoint, arrow goes to the right. When we take a look at a line is actually made up of a pair of what are called opposite rays. And the picture that I've drawn here, ray BA, so the ray starting at B and going through A, and ray BC are a pair of opposite rays. Opposite rays have to have a common endpoint, and they always form a straight line. In geometry, when 2 objects have the same shape and size, they're said to be congruent. So congruent segments are two segments that have the same length. So if I draw two little segments here, line segment AB and line segment CD, if I said that each of these was 4 centimeters long, then we have a pair of congruent segments. So we can show that in notation form with a little symbol. First, write the notation for segment AB, line segment AB, and line segment CD. Use those endpoints, symbol above, and then we use the symbol for congruence in between. It's an equal sign with a little wavy line above it. So this would tell us that the two objects are the same shape, same size. If we wanted to just say that these two segments have the same length, then we would just write down the endpoints without the symbol above. That means the length of segment AB, and we're just going to say that that length is equal to the length of segment CD. Okay, so I know it's a slight difference between the congruent symbol and the equal sign, and AB with a line segment above it and AB without a line segment above it. But when we don't have the line segment above it, we're talking about the length of the segment. The midpoint of a segment is the point which divides a segment into two congruent segments. If we are given this line segment AC, and we were told that B is the midpoint of AC, then we can conclude that line segment AB is congruent to line segment BC, or we could also say that the length of line segment AB is equal to the length of line segment BC. At the bottom of your first page of notes, if you would copy down the above definition, the bisector of a segment. It's a line, array, segment, or plane that intersects a segment at its midpoint. So for example, if we had a line segment, and we refer to those endpoints as x and y in this case, and we had point P, that was the midpoint. If P was the midpoint of xy, then any line that came through point P would be the bisector of line segment xy. So let's call this line L, and we can say that L bisects segment xy. By the definition, a bisector of a segment can also be a ray, so it could also be a segment. If we went from point P, and let's just draw a line segment, to point Q, then we can say that line segment PQ bisects line segment XY as well. There are two different methods that can be used to find distance on a number line. In our first question, it says, what is the length of the segment from point D to point G? So if we talk about the length of a segment, we're talking about DG with no symbol above it. We want to know how far apart these 2 points are. One method which we can use is the counting method. We can count the number of spaces between point D and point G. 1, 2, 3, 4, 5. So we know that the length of that segment from D to G is 5 units long. But sometimes our points are far apart, or sometimes they have fractions or decimals as their coordinates. So instead of using the counting method, we want maybe a little formula to use. Okay, so keep in mind that distance always has to be positive. You would never say I ran -2 miles today. Right? So distance, we're going to find the absolute value of the difference in the coordinates of the 2 points. So I'm starting my absolute value sign here. Then I'm going to take the coordinate for point D, which is -3, and I'm going to subtract the coordinate for point G, which is 2, from that. And after I do the math, I'm going to take the absolute value of the number. So negative 3 minus 2 is negative 5, but the absolute value of negative 5 is positive 5. And you can see that our distance of 5 units matches what we found by using the counting method. So for example, in the second question it says, what if point D had a coordinate of negative 3.2 and point G had a coordinate of 7.4? And this is what I was referring to earlier. We don't want to try to use the counting method here. Let's try our little formula. So from G to D, I'm going to say we'll take the absolute value, take the coordinate of G, which is 7.4, and subtract the coordinate of D from it, which is negative 3.2. So I started a little parentheses there. Well, we know that when we subtract a negative, it turns into adding a positive. So take 7.4 plus 3.2. We have the absolute value of 10.6. Distance is always positive, so DG would have a length of 10.6. Now I said DG, but remember, we can refer to that line segment as GD or DG. In geometry, we have our undefined terms. We also will be studying definitions, postulates, corollaries, and theorems. Our first postulate is called the segment addition postulate. And it says, if B is between A and C, then the length of line segment AB plus the length of line segment BC is equal to the whole entire segment AC. Now, the word between is very specific in definition in geometry. In order for a point to be between two other points, all 3 points must be collinear. They all have to be on the same line. In other words, if I drew point A here and point B here, and I had point C here, B is not between A and C. Likewise, if I had a line segment where the endpoints are A and C, and I put point B either above or below the line segment, we could not say that B is between A and C, because again, all 3 points are non-collinear. Okay, back to the postulate. So this segment addition postulate, what we're going to do is set up and solve an equation in order to answer the question in example 1. In example 1, it says if AB is equal to x, so I'm going to label line segment AB with an x above it. X represents the length of line segment AB. And BC is equal to x plus 6, so do the same, label that. And AC, that's the whole entire segment. It has a length of 24 units. We're being asked to find x, AB, and BC. And watch out for questions like this. Very often we'll have a question where we have to solve for x, but then there will also be a follow-up where you have to find some other specific measures as well. So in setting up our equation, if you take a look at the diagram and using our postulate that says AB, the length of AB plus the length of BC is equal to the length of AC. So AB is equal to x, so substitute x in for AB. BC is equal to x plus 6. And AC is equal to 24. And check it out, you have a little algebraic equation to solve. Add those like terms on the left side, you know how to do it. 2x plus 6 is equal to 24. Continue solving, so isolate the variable on the left by subtracting 6 from both sides. 24 minus 6 is 18. If 2x is equal to 18, to solve for x we need to divide both sides by 2. So x is equal to 9. Remember, don't stop here. Make sure you answer the question. This one's pretty easy. We have x equals 9. AB was represented by x, so AB is equal to 9. There are 2 different ways in which you can solve for the length of BC. You can do it by plugging in 9, where we see x, in this algebraic representation for BC. So BC would be equal to 9 plus 6, or in other words, BC is equal to 15. So we've answered all 3 questions. And of course, you can go back and check our work. Make sure that 9 plus 15 is equal to 24. All right, now it's your turn if you would complete the in-class practice problems at the bottom of the page.